So this is 3.3, and we're going to call it A for obvious reasons. Polynomial division, the remainder and factor theorems. Okay, good friend of mine, he always said that in math when he was in school that the hardest thing for him to figure out was the gazintas. And I'm like, what the heck are gazintas? And he's going, like 3 goes into 6, 5 goes into 25, 10 goes into 100. He always had a hard time with his gazintas. So that's what we're going to look at is division. All right, so when you're looking at factors of a number, like the number 27. Okay, factors mean what numbers divide evenly into 27. Well, 3 does, 9 does, and that's it. Okay, 4 does not. And how do you determine if they divide evenly into that? Well, let's go back to 4th grade. We do this, and we say 3 goes into 27 9 times. 9 times 3 is 27, with 0 left over. We know that 3 goes into 27 because we get 0 as a remainder. Now what if I did 27 and I did 2? 2 goes into 2 once. Bring down the 7. 2 goes into 7 3 times. 3 times 2 is 6, and I have 1 left over. So that tells me that 2 does not go evenly into 27, or is not a factor of 27, because we have a remainder. So we determine whether or not numbers are factors based on whether we get a remainder or not. The same is true when we're dealing with polynomials. We can determine if certain polynomials are factors, or certain things are factors based on whether or not we get a 0 for a remainder. So, for example, if we have a polynomial of x cubed plus 2x squared minus 5x minus 6, and we're trying to find the factors. Okay, so I know I'm just going to tell you right up front that these are the factors. Okay, and I know these are factors because if I do this really disgustingly evil division here and divide it by any one of these, let's say x minus 2, and I do the long division, okay, and I just keep doing all of this, and I, go da all the way down, I get as a remainder 0. So check that off. That is a factor of that. Okay? And when I do x plus 1 and I do x plus 3, I also get remainders of 0. So that means that each one of these are factors because when I do the long division here, I get a 0. So what does that mean? That means if I say, is x plus 3 a factor of this? You don't know for sure unless you do this long division here and get a remainder. How would you like to do this long division for each one of these in order to find out if your remainders are 0 and can therefore say each one of these is a factor? You wouldn't unless you're a psychotic lunatic. Then you would like to do that. Okay, but we are not in a place where we want to do that. So what I'm going to do is show you a handy-dandy skill called synthetic division that's going to help you to determine whether or not there is a remainder that's painless and doesn't involve all of this long division. Because remember in the last lesson when we had these really, really long polynomials and I said in lesson 3.3 and 3.4, I'm going to show you a way to determine what the factors are of these polynomials so that you can tell where they cross the x-axis. Okay? You have to get all of your polynomials down to what are called, and we've mentioned this before, linear factors. Like on this long one that I just put up, we had x plus 3, x plus 1, and x minus 2. These are all linear factors. The exponents on the x's are 1s. So that means they're linear factors. So that means we cross the x-axis here, here, and here. But if I had the original problem down, I can't find out where they cross the x-axis. It's impossible. I know where it crosses the y-axis at -6, but I don't know where it crosses the x-axis. So I have to factor it down into linear factors, so then I can find out where it crosses at those 3 points. And again, this is a cube, so that tells me I'm going to cross at 3 points. Alright, so just some idea of what we're going to be doing here. So we're going to try to find the factors of a huge polynomial like this using division. And in this case, we're going to use synthetic division. And if you've had Algebra 2 with me, I've taught you synthetic division, but we're going to go over it again just so that you are reminded. So, what does it mean? Let's say, for instance, I took this equation here, and I told you that the factors of this were, what did I say, x plus 3, x plus 1, and x minus 2. Those are the factors that give me a remainder of 0. So, what does that tell me? The answer for this, where it crosses the x-axis, is -3. So it crosses there, and crosses, whoops, 2, crosses there. Alright, so again, what are the remainders when I divide this into this? If they are factors, the remainder will be 0, right? The remainder is also the y value. In this case, it's 0, because that's where that means it crosses the x-axis. It's 0, it crosses the x-axis. It's 0, it crosses the x-axis. What if I plugged another number in and divided? So let's say, for instance, I tried, instead of -3 to kick out a 0, let's say I tried a positive 4. And then, so I put 4 in here, and it will kick out a y value, right? And that y value will be 24. Well, if I divided x minus 4 into x cubed plus 2x squared minus 5x minus 6, what is the 0? What makes that 0? This positive 4 right here. So the number I'm trying to find out if it's a factor is going to be x minus 4. Alright, so if I do that, I get all of this junk up here, and I get a remainder then of 24. Interesting that our remainder is always the y value to the x that I tried. Okay? You seeing how that works? So when it is a factor, when -3 is a factor, makes that 0, it's going to give me a remainder of 0, where it crosses the x-axis. My y value will be 0. It doesn't go up or down. But when I try a number that is not a factor, it's going to give me a remainder that happens to always be the y value. So I can graph this point. It will be on this graph of this. It just won't be where it crosses the x-axis and won't be one of the answers. It doesn't mean it's not important. It just means it's not one of the places where it crosses the x-axis, but it's still on the graph, if that makes sense. Alright, so I am going to skip 2 pages of information on the whole synthetic division part, and I'm just going to show you how it works instead of showing you why it works. Okay, because most of the time we just want to know how it works. So we're going to take that polynomial and divide it by this one. And again, we divide that so that, and let me write it long division ways, we do it this way to find out if x plus 3 is a factor of this polynomial. If it is, then we get a remainder. If it is not, we get a remainder. So a remainder of 0 means that it is a factor. A remainder other than 0 means that it is not a factor. So synthetic division is not tricky, but there's a lot of things to it. So you're going to have to just really pay attention. All right, so notice I made a little box here. The number that goes in here will always be the number that makes this 0. Okay, and then we're going to put a bunch of numbers right along here. And those numbers are going to be these numbers right here. One of the things that's necessary, notice how this goes, 3, 2, and then 0. We're missing an x in here. Okay, so what we're going to do is wherever there's something missing, we're going to have to put a place value there. So we have an x cubed, an x squared. We have to have an x here, so we're going to have 0x and then our 5. So what we're going to do is we're going to list just these numbers here. So we're going to put in a 2 here and its sign, a 7 here. We don't have any x's, so just put a 0 there, and then we have a negative 5. First step is we're going to bring this 2 down here. One thing that's important is this number here always is multiplied by the bottom number here, and that answer is put right here all the time. This times this here, this times this here, this times this here. Okay, so let's go ahead and do that. Negative 3 times 2 is negative 6. Now what? Whenever you do this part right here, you add, and then we get a number right there. And then negative 3 times 1 is negative 3, which goes right there. Add. Negative 3 times negative 3 is positive 9. It goes right there. Add. Okay, at this point there's nothing left. That last number is the remainder. Since there is a remainder of 4, this is not a factor of that, but they didn't ask for that. They asked what the quotient was. If you take this divided by this, what do you get? All right, this is all I care about. So we get for an answer 2x, and it's always going to be 1 less than that, plus 1x, always be 1 less than that, minus 3. Okay, we don't have any more x's left, so there's no x's in that third one, with a remainder of 4. Okay, so we get that. So these will always be, your answers will always be exactly that, 2, 1, 0. Like up here, it skipped the x that we had to put a place value of a 0 there. It won't be that way in the answer. It'll always be 2, 1, 0. Unless you get like this number right here is a 0, then it would be 0x, which you could still write it. But anyway, so this exponent here will always, always, always be 1 less than this. And then you just go down from there, 2, 1, 0. And then if there's still a number there, that ends up being your remainder. Okay, so that's it for this video, and we'll go on with example 3 in 3.3b.